Welcome to my pre-algebra class. We're on chapter 14, section 4, and we're going to be finding volume of prisms and pyramids. The volume of a three-dimensional shape is the amount of space that's enclosed by the figure. And there's a general formula for volume. It's volume equals the area of the base figure, whatever that might be, times the height. And the base figure can change. So basically what we're trying to do is see how many, like in this rectangular prism, how many rectangles we can stack inside. And in a triangular prism, how many triangles we can stack inside. And in a cylinder, when we get to that, how many circles we can stack inside. So the volume of this rectangular prism is found by capital B times H, and we're going to replace the B with the formula for the area of the base figure, which is length times width, because it's a rectangle, and that's going to be times height, which gives you your old formula for volume. So our length is 15, our width is 4, and our height is 8. So the total amount of space inside, get our calculator back, is 15 times 4 times 8, and it's 480. And remember, volume is how much space we have inside. So what we're actually doing is finding, since this is a meter, how many little cubes, 1 meter by 1 meter by 1 meter. So we have 480 cubic meters. This time it's to the third power. So I can fit in 480 of these little cubes inside here. The second shape is a triangular prism. I use the same formula, volume equals capital B times H. This time I replace the base, the capital B, with the area of the base figure. So I have to substitute in 1/2 base times height, because that's how I find the area of that triangle, times the height of the actual prism. So in this case it's 1/2, the base is 4 and the height is 6. And if I turn this prism around and set it on its triangle, it's 8 meters tall. So 1/2 of 4 is 2. 2 times 6 is 12. 12 times 8 is 96. And there are 96 cubic meters inside that triangular prism. Then we get to the pyramid. The volume of a pyramid is a little bit different because I can't see how many rectangles I can stack inside, because as I go up, each rectangle is getting smaller and smaller and smaller until I reach the point up here. And the formula, and you'll learn how that was obtained later on in higher mathematics, is to take 1/3 of the area of the base figure, in this case a rectangle, so length times width, times the height. And that'll take care of the rectangle, whatever shape it is, getting smaller and smaller inside. So it's 1/3, length is 12, the width is 4, and the height is inside. The height from the bottom of that rectangle to the top of the pyramid is 8. So I could cancel the 3 with the 12, and now I have 4 times 4 times 8, which is 128 cubic meters. Okay, we're ready to start the assignment. So we're on 644. It's exercises 1 to 16. Problem number 2. Find the volume of each base figure with the given base and the height. I actually have worked out whatever the base figure is, its area. So we don't have to worry about that for this one. We just substitute in the 19 centimeters squared, times it by the height, and we're done. Let's slide this over and get our calculator up. So that's going to be 19 times 12, and we get 228 cubic centimeters. Problem number 4, find the volume of each base figure. Well, number excuse me, I'm still in the top part. Volume equals the area of the base figure times the height. The area of the base figure is 25, and the height is 9, so we're going to take 9 times 25, and that'll give us our volume, which is 225. And the unit was meters, so it'd be meters cubed. Problem number 6. We have a triangular prism. Our formula is that volume equals the area of the base figure times the height. So we have this triangular prism. And its sides are 6 and 6 for the triangle, and here's the right angle right here. And the height of the prism is 5.4. So we're going to replace the V. You have to do this with each problem. You're going to rewrite the formula with the more exact formula. The base figure is a triangle because the triangles are opposite and identical. So we're going to use 1/2 base times height for the capital B, and then we're going to times it by the height of the prism. So in this problem, the base and the height of that triangle is the two sides that make the right angle. It's 6 times 6, and the height of the prism is 5.4. So we could cancel the 2 and the 6 and get a 3, and then use our calculator and take 3 times 6 times 5.4, and we get a volume of 97.2. And the unit was centimeters cubed. Problem number 8, we have a pyramid. The volume of a pyramid, remember the base keeps getting smaller and smaller until it reaches the point. We have to do 1/3 the area of the base figure times the height. Okay, the base figure, look carefully at that pyramid. It looks like we have a triangle as the base. And the height of the pyramid is inside, and they have it as 5. And then they have that right angle right here. So these two sides make the right angle, so those are the base and the height of the triangle. So we got to replace this with the formula for the base figure, which is 1/3 times 1/2 base times height. We have to substitute this formula in times the height of the pyramid. So now we have 1/3 times 1/2. The base and the height of that triangle are 3 and 4, and the height of the pyramid is 5. So it looks like we could do some canceling here. 3's cancel, the 2 cancels with the 4. And what we have left is the 2 and the 5, so that comes out 10. Unit is yards cubed. That worked out nicely. Problem number 10, we have another pyramid. It's a triangle. And it's kind of like upside down. And the base is a triangle, so we have this. And the right angle is right here. So this is 5, and this is 8. And this side is the height, which is 9. So volume equals 1/3 the area of the base figure times the height. And again, the base figure is a triangle, so replace the B with 1/2 base times height times the height of the pyramid. So we have 1/3 times 1/2. The base and the height of the triangle are the two sides that make the right angle. So that's 5 and 8. And the height of the triangular pyramid is 9. Right there. So again, looks like things will cancel out easily. The 3 goes into the 9, 3. The 2 goes into the 8, 4. So we have 5 times 4, which is 20. Times 3, which is 60. So our answer is 60 cubic inches. Problem number 12, we'll draw a picture of this, a rectangular prism with a base of 10.5 units, a base length of 10.5, a base width of 8, and a height of 6. So we just have a rectangular prism. And it said that the length was 10.5, 10.5, we can use that. The width is 8 and the height is 6. So volume equals the area of the base figure times the height. The base figure is a rectangle, so we'll replace B with length times width times height. The length is 10.5. The width is 8 and the height is 6. So using our calculator, 10.5 times 8 times 6 gives us a total of 504. So our volume is 504. And they just said units, so we just say cubic units. And 14, a square pyramid. So we're going to draw a square at the bottom, and we're making a pyramid. And its edges, the base is a square, so it's 11 by 11, and the height inside, how tall the pyramid is 7.2. So volume is a pyramid. We have to take into account that the square keeps getting smaller and smaller as it gets to the top. It's 1/3 the area of the base figure times the height. The base is a square, so that's just side squared to find the area of a square times the height. So it's going to be 1/3 times 11 squared times the height, which is 7.2. Now, 3 will cancel into that, but I'll show you how to do it with a calculator. Take 11, square it, times it by 7.2, get the equal, and then since you're taking 1/3 of it, it's the same as dividing by 3. And the answer is 290.4 meters squared. Excuse me, cubed. Now the 3 would have gone in there. 2.4, you could have done that too. It doesn't matter. Okay, the last one, 16. A tent is shaped like a square pyramid. So here we have our square pyramid again. And it has a height of 2 meters. And the bottom, remember, is a square, so it's 3 by 3. We're going to find the amount of space inside the tent. Volume equals 1/3 the area of the base figure times the height. So it's 1/3, base figure is side squared, it's a square, times the height. So it's 1/3, 3 squared, times 2. Now if you don't want to use a calculator, it'd be easy this time. 3 squared is 9. You got to square first, times 2. And we can cancel. And 3 times 2 is 6. So our answer is 6 meters cubed. That concludes the evens. Be sure you check the back of the book for the